Hello everyone, it's time for another video with Mr. Tom and STEM Kids in Space! Today's topic, we're going to have two topics. They are drag and center of gravity. Here I have a rocket. We'll use our imaginations, pretend this is a rocket. Here is the bottom where the engine is, exhaust coming out. Here the pointy end. This is where our payload is. We talked about the parts of a rocket in another video. So we're going to be sending this up. Now at some point we may turn off the engine. We may be turning off the engine because we have multiple stages and we're going to drop off the first stage and then light the second stage. And there may be a brief moment of time where in between the two stages where we're just going along, we're not pushing. And at that point, it's possible that, especially if we're still in the atmosphere, that our rocket is going to want to adjust and move along the center of gravity. What's the center of gravity? Well, center of gravity has half of the weight on one side, half of the weight on the other side. Or we might say half of the mass on one side and half of the mass on the other side. Let's say our engine is very heavy. So that would actually move the center of gravity over here so that there's more weight over here to equal or balance this side. Otherwise, if the rocket engine is heavier and everything else is equal, we're going to be out of balance. Now there are different places in a rocket where there is weight. So if we remember this visual before, where we have our payload, we've got some fuel and we've got some oxidant and we've got our rocket engine. Let's say we've turned off our engine. And we've got some oxidant and some fuel left. These are not necessarily correct. This is just a visual. Well, these may weigh different things, and our center of gravity may be higher or lower. And what's going to happen is, as this rocket is flying, it's going to want to fly with the center of gravity in the middle, which may be down here, or it may be up here. And that's why when you shoot a bow and arrow, I used to have a bow and arrow, but when you shoot your arrow from the bow, you push it. And now it's just flying. It's no longer being propelled, it's just going in space. And what's natural for the arrow to do is start flying to the center of gravity of the arrow. So what do we put on the end of an arrow? There's little feathers at the end. And those feathers create a little extra drag, and they push the center of gravity in such a way that the arrow keeps flying straight. If they're too heavy, well, gravity is going to pull the arrow down faster. And experiment where to put them and whatnot. So you may see rockets that will have fins similar to feathers to help guide and move the drag and the center of gravity such a way that the rocket keeps flying straight. So I have put some fins at the bottom of my rocket. Now rocket engineers have many choices, many options they have to make so that everything works together. Are they going to put the oxidant on the top or the bottom? Are they going to put the fuel on the top and the bottom? Are they going to put the payload up here? Maybe they're going to put it down here. Maybe we want some other fins up here. All sorts of things that we can choose to do. So here's an experiment. Now my kids used to have a ball that had a long tail on it, and you could spin around, you could throw it up in the air. We don't have that anymore. So I've got a bread bag and I've got a ball. Where's the center of gravity? This is pretty light. This is heavier. This is so light compared to the baseball that the center of gravity is going to be almost in the center of the baseball. What happens if we throw the ball holding on to the ball? How will it fly? What if we throw it by swinging it around and then letting go? Which side's going to go first? Well, the center of gravity is up here by the ball. It's going to fly this way. What happens if we take our ball in our bag and we throw it up like this? Throw it straight up. So the heaviest part of the bottom. If you throw it up high enough, it will probably rotate around. Now we're throwing balls up in the air. What should we do? Safety. Let's make sure we have some safety. So this is an activity you can do yourself. Get a bag, get a ball, put it inside, tie it down so it stays on one end. Throw it first, baseball first, then with the same amount of force, throw it by swinging it. Which end goes first? Toss it straight up in the air. Does it turn around? This will go like this. Throw it like this. Which way is it going to go first? So that's a fun activity. Another activity that you can do is shoot a bow and arrow. How does it fly? Pointy end first, feathers in the back. If you have a arrow that is missing the feathers, sometimes that happens. Make sure you're wearing your safety goggles. Shoot that one and see what happens. What if the tip's been broken off? That happens a lot too. How does that fly? There we've got aerodynamics, we've got drag, center of gravity, all working. That arrow has been balanced just perfectly, just right, designed how it is to fly perfectly. What about our rocket? The engineers, rocket engineers, have to figure this all out. Maybe they're going to put some little thrusters on the side to help maneuvering. Maybe the rocket engine needs to rotate so actually when it's going up, because there's drag coming down and center of gravity, to help it go in the direction it wants. Maybe these fins move. All sorts of things you can do, many decisions. If you watch rocket launches, you will notice that they're not all the same. Now, one type of rocket, they usually look the same. There will be minor variations, but different countries, different companies have different designs because they have different purposes. They have made different choices. That's it for this video. Keep enjoying space. Until the next video, this is Mr. Tom and STEM Kids in Space.